Hi, everyone, and welcome to today's Sip and Solve. I'm Marsha Silverman, and I'm an analytic consultant in experienced commercial decision sciences. That's our analytical group within our commercial or business-to-business division. Today, within just 15 minutes, I'll be walking you through how you can determine if an off-the-shelf model will meet your needs or if you should pursue a custom model build. That could be a big decision, and knowing which way to go from the beginning will help you out a lot. I'm over on the East Coast, so it's the afternoon here. I have a tall glass of water washing down my lunch. I hope you have something good in front of you to enjoy this Sip and Solve while we talk for about 15 minutes. Now, I'm sure that all of you know at a conceptual level what models are, and most of you probably use them regularly. But some of you may not be numbers and analytics geeks like I am and fully understand the purpose of models and how they work on a day-to-day basis. We won't get into too much nitty-gritty here, but I've laid out some of the basics. Simply put, a model predicts something. It's a mathematical algorithm that distinguishes the relationship between random information and an event. In simple terms, if you have 100 gumballs in a gumball machine and there are 50 red ones and 50 blue ones, if you take 10 gumballs out of that machine, you would expect to get 5 blue and 5 red. That would be a random sample, and you would expect them to come out in proportion of the total sample. Now, if you prefer blues over reds, you would like to have a model that could predict getting the blues instead of the reds. And so then if you select your 10 using that model, maybe you get 8, 9, or even 10 if you have a really great model, all blues. And you can leave the reds for somebody else who likes those. In real terms, we wouldn't be selecting gumballs, but we may have models that could predict some things that are listed on the page here, like will an account go delinquent, will a prospect respond to a marketing offer, and who may be able to pay that's in a delinquent status. As we go forward here, we'll talk a little bit about some of the terminology you may hear, just so that we're all on the same page. A target variable is the outcome or the objective function of the model. It's what we are trying to predict. The score is the estimation of that target variable. You may hear other terms like prediction or p-hat or output of the model. It's really what comes out of the model and says it's the probability of the occurrence of that target variable or that outcome. Then the other component of models are the predictors. Those are the variables that go into a model that are expected to somehow mathematically predict that outcome or target variable. At the bottom of this slide, I have some of those types of predictors listed. At Experian, we have our business aggregates, SBC aggregates, as well as our consumer premier aggregates attributes. Models can be developed to predict almost anything. As I mentioned earlier, we could say, what color is a gumball? That's not really practical in our business world, but here's a fairly comprehensive list of things that could be predicted across the life cycle of an account in both the risk and marketing areas. Then the question is, when you're looking at a model, how do you know if you should use an industry model that's out there versus a customized model for your portfolio? And there are many industry models out there, and the question is that industry model that may be kind of like a one-size-fits-all better or good enough rather than investing in a custom model? An off-the-shelf model is like that one-size-fits-all suit that you could see this pictured here. It may look good enough on a number of different size people. You know, it could fit shorter, taller, it could fit wider, thinner, but when you go to a custom tailor, you're going to get a suit that fits you perfectly. So a generic model or an off-the-shelf model, industry-wide model, are built on general, broader populations than any one specific portfolio. It may be predictive of your portfolio, but it may not be that predictive or as predictive as other models could be. So the way to determine if that one-size-fits-all or off-the-shelf model is good enough for your portfolio is to perform a score validation, and that can determine if this one-size-fits-all or generic model is good enough for your portfolio. How do we perform a model validation? Well, we would start with a population, and I have an example laid out here that shows accounts opened in first quarter 2018 as the example. That would be our observation point. And what we would do is look at the data that's available as of that time when the account is about to be opened, and you score them with the generic models at that observation point. Then you determine how well does that score at the time that that account opened predict the actual behavior you saw. So in this example on this page, you see a bad is the behavior we're trying to predict at 91 or more days delinquent, and a good would be anything that doesn't have that bad performance. You could see here on this slide that the observation point being Q1 2018 with a 12-month performance window would end the performance period in Q1 2019. And so again, we would score them at the observation period. Knowing their actual behavior over that 12-month window, we would then see how well does the score predict the actual behavior that was observed. And with that, we can determine how well the score fits your portfolio. Now, how do we do that? How do we know that the score is working? One of the key metrics that measures the predictability of a model is the KS score. Some of you may have heard of it before. That's short for Kolmogorov-Smirnov measure. And what this measure does is it indicates the degree of separation between the positive and negative outcomes. So how many goods versus bads in the model, and the chart shown here is a plot of goods versus bads. Now, the black straight diagonal line across this chart indicates what you would expect from a random sample. So if you picked 20% of the population, you would expect 20% goods and 20% bads. And in my earlier simple example, that's where you would expect 20% of your blue gumballs and 20% of your red gumballs. Again, even distribution based on the overall population for a random sample. And that's, again, that black diagonal straight line. Now, when you model, what you're trying to do is predict the goods versus the bads and separate them out. And those curved lines, the blue versus green, are examples of predictive models that would get you better than random. And this KS measure measures the distance between that random line and the curves that are modeled. KS score goes from 0 to 100, with the higher being more predictive. 100 would be perfectly predictive. So if you had those 100 gumballs, 50 reds and 50 blues, if you could select 50 gumballs and get all blues, that would give you a KS of 100. There are some other metrics that we also look at. And on the next slide here, this is a sample odds chart. So what we would do is look at the scores by decile. So it's 10 approximately even populations across the total sample. And we lay out by those score ranges how many goods and bads and the bad rates. Here you just have the cumulative and decumulative, and you can see where the KS is. So in this example, the KS is the highest point between that random line and the curve is down in the 15 to 25 score range. That KS hits 0.24. And so a 24 KS is a good metric saying that the model is predictive and indicating that the model is doing what you want it to do. Another thing besides KS is right in the middle of this chart, we have what's called bad rate int, which is interval, the bad rate for each interval within each decile. So the top decile, which has the highest scores, 97 to 100 score on the left, with a 3% bad rate, you can see that that interval bad rate increases steadily all the way to the bottom decile with the lowest scoring, scores of 1 to 6, up to a bad rate of 16.4%. So what this tells us is that the model is ranking the goods and bads and separating them out really very well here so that you can say, I want to take out those riskiest accounts at the bottom scores where you have really high bad rates, but you want to bring in those accounts that could score high and have very low bad rates. Now, what this is measuring here is the incidence of bad. So it's just how many times does an account, how many accounts go bad. Now, whether they go delinquent for $1 or $100 or $1,000 or $1 million, that may make a difference to you too. So you may say, this is a good indication that the model ranks, but is it ranking really what I would like it to rank? And so what you could do is take it one step farther, and the left-hand part of this chart is exactly what you saw on the prior page that has the incidence rates. But now on the right-hand side, you see all these dollar amounts. And so this is measuring not just the times gone bad, the incidence of bads, but the good versus bad balances and how much is going to be estimated losses versus your profit on this. And you can see that the profit margin and the charge-off rates are estimates on the top. And you can estimate your net cumulative profit. And what this does on this odds chart with these dollar amounts, you can pick out where you maximize your revenue or maximize your profit, pardon me. And it's highlighted from the third row up from the bottom at almost $3 million, the $2,988,000 in that score range of 9 to 14 is where you can maximize your profit in this example. And so given this, and you've now done this score validation, this generic score may work for you, you can pick that score range is where you may want to cut off and say, I don't want to approve anybody below this score, and above this score, I would be willing to approve them because it will maximize my profit. So this is an example of doing a validation, and the score is predictive, and you can get value out of it and go forward and use this score. Now, in my experience, it doesn't always come out this well, and when it doesn't, that's when you may want to turn to a customized model build and get that perfect fitting suit for your portfolio. Well, that's all I have for you today. I hope you enjoyed this session, learned a little bit, had a nice break with your coffee or tea. If you'd like to join us in the future, please sign up on the with the link. And if you have any questions or would like to chat with us, you can go on that link that's on the slide. And have a great day.